Hello, my name is Kanikella Ruthu Evangeline with ID number S4206574. This video is about the game Minecraft. Uh, People will call in very different ways. So, this is all about the game, and we are training the model to play the game. Um, and this is the analysis of the paper. So, nowadays we can see that AI is artificial intelligence is everywhere. Like wherever you go to the malls or restaurants, you can see robots and technology everywhere. Like the manpower is decreased in vast way, and the technology is increased in such a numerous way, because when you go to some restaurant, so the robots are coming to serve you the food, right? So in such way, like in malls or something like that, even for cleaning, for putting the things in the right way, we are using robots and the machines, AI machines. Particularly, we are training the model, we are telling the model to act in a particular way, and it's going to act in that way. This is all about artificial intelligence, and here we are discussing same the agents, artificial intelligence, like one of the topic of the artificial intelligence. So yeah, this is the analysis of the paper. The paper is all about the playing the game Minecraft with the video pre-training. It's a kind of model. We are coming to the first slide. Um, you can see motivation and significance. What is the importance? Like why we have chosen this paper especially? As you see, as I told that AI is like very much increased nowadays. Like it's getting involved in day-to-day lives also. So the motivation is to get a very good accuracy, like efficacy of video pre-training with the large and unlabeled data sets. Like we should time the videos also, because for machine learning, if you give some input like okay, if this person reacts in this way, you give that input. So we will train the model in that way. But here we are training the videos, like we are training the model in the form of videos. Okay, so, the first documented work that shows promising results using semi-supervised limitation leading to large, noisy, and freely available datasets for sequential decision domains. So here, game is all about decisions, right? We know that. So if you want to take one step, then okay, the person is going to the first step, so the environment acts in that way. So if you stand behind, like if you hide between the trees or you hide between the rocks, so you cannot shoot the other person, like you cannot go to the other person. So this is all about decision making is also an important component thing in this uh, paper. So yeah, demonstrates that video pre-training and fine-tuning allows agents to solve tasks that would be otherwise impossible to learn. So yeah, some things were impossible to learn, but we are fine-tuning and allowing agents to solve the task. So we are involving agents to solve the complicated tasks here. Shows that labeled contracted data is more efficacy used with the video pre-training method than it would directly train the foundation model. We can discuss further what is the foundation model, pre-training method, and all. Yeah. Moving to the next slide. What is the methodology? What is the prominent methodology that we are going to use here? So the first one is like inverse dynamic model. What is this inverse dynamic model? It's a model of artificial intelligence. An inverse dynamic model predicts the actions or inputs needed to achieve a desired outcome based on observations of the system's behavior. It's commonly used in control systems and reinforcement learning to guide agents towards specific goals. So this is like IDM and data filtering. You know that data filtering. When we heard about it, some techniques will come into our mind, like data mining techniques and all, right? So because video is all about the noise, huge amount of volume and all. So if you want to filter the data, you need to use the methodology data filtering. The third one is repeated foundation model. What is it? what is this VPT foundation model? It is the video pre-training method overview. Okay, so this VPT foundation model is like video pre-training model. It's a method we call where a model is trained on a large data sets of videos to learn useful representations. These representations capture information about objects, actions, and scenes in the videos, which can then be fine-tuned for specific tasks like action recognition or video uh, capturing. So this video pre-training method, you can see that because we are training the video, we need to uh, like train the video in such a way that it should react to the situations, like it should react to the scenes, it should react to the uh, uh, specific task that the person is doing. So in such a way, we are going to train the model. So this is the methodology we are using here to train the model. So this is the clear overview of VPT. Here you can see that we are collecting the data from various keywords, like we are doing so many comps and collecting the data, and we are filtering the data, and then we are giving to behavioral cloning, and then we use this IDM. IDM is also one of the ideology or methodology we are using here. So here we'll give the contacted collected data. Um, to the system, and there it just refines, like it gets fine tuning, and then again it gives to the behavioral cloning. Here you can see that training the VPT foundation model via behavioral cloning. Yeah, this is the methodologies we are using, and here the strengths and limitation of methodologies. So the strengths are inverse dynamic model is easier and more data efficient to learn. As I said, like the methodology we used here, like IDM, is much more easier, so it became one of the strength of the total model. So deep learning training is low variance, mitigating impact of hardware limitations and computational cost. So deep learning training is like low variance, mitigating impact, hardware limitations. Like it, you can see that the computational cost is like very comparatively okay. The limitations, like more data could be, like we should get more data because we are training a model to play the game. So you need to get huge amount of data, and filtering all that amount of data is also a limitation here. So yeah. So what are the results of the model we are getting here? The performance of IDM is like the methodology we are used IDM, and it is giving 90.6 K accuracy. So here you need to observe. So when you do the machine learning models or deep learning models, you'll get 90%, 98% accuracy. Sometimes nowadays, based on the technology, people are getting 99, 100% accuracy also. But here you are playing such a complicated game, that too with a model. So you should react to the actions, you should react to the scenes, you should react to the specific tasks that you are given in the game. So it performed very well. I could say like it is a very good accuracy that we got. It's like 90.6 plus accuracy. So yeah, behavioral cloning fine tuning performance improves as a video pre-training model trains. So these are the experiment setup and the results we got. So this is the conclusion. Like like it allows, like our model will allow in the future also, if you bring something video, so the model can learn depending on that video. Like it can gain some information from the video, and it can act according to the input you have given. So it offers the possibility of learning large scale behavioral prayers. So the game is all about behaviors, decision making, and all. So you can the possibility of learning is very much high. So this is all about the model that we designed for the game Minecraft. So these are the references, these are the books we have gone through, and many videos like OpenAI videos that are available in the internet. So This is the game Minecraft, and we designed a model which is the VPT model to play the game using artificial intelligence agents. Thank you so much for listening.